In section 2.5, we're going to reason using algebra properties. This is actually the first section where we're going to start doing real proofs. The good news is that we're kind of easing into it because we're going to use properties that we learned last year in algebra, and we're actually solving some equations today, and then that's going to help us get into geometric proofs that will begin soon. Starting out, we're going to talk about algebraic properties of equality. This is actually, you use these properties every time that you solved an equation last year. The algebraic properties of equality are addition property of equality, subtraction property of equality, multiplication property of equality, and division property of equality. You notice I started abbreviating property of equality as PO, and you can do that when you're writing out the steps today in your homework. Addition PO, subtraction PO, multiplication PO, division PO. Now, what each of these say, and these are the steps you did when you solved every equation last year, is that you can add or subtract or multiply, divide, as long as you're doing the same number on both sides of an equation. That's what these properties of equality tell you. If you decide you're going to add 2 on both sides, you're doing addition, property of equality. If you decide you're going to divide by 4 on both sides, you're doing division, property of equality. It's saying you can, add or subtract or multiply or divide, same number, both sides. You used these last year all the time. And another property is substitution PO, or property of equality. Now substitution, we dealt with a lot last year as well. That says that you can basically substitute one for another if you know two things are equal. Like if A equals B, you can substitute one for the other in any equation or expression. If you knew that A equals B, instead of A you could put B. Instead of B you could put A. Quick example of that, if you knew that X equals 4, then you could say that, like let's say you had to do 3x plus 2. You would substitute, now that you know that x is equal to 4, instead of x you could put 4, and you would do 3 times 4 plus 2, and you would figure out what that was. So that is substitution PO if you're plugging in one thing for another. So you have addition PO, subtraction PO, multiplication, division PO, saying you can add or subtract or multiply, divide, same number both sides, substitution, plugging one thing for another when you know they're equal. And we're going to actually start some proofs. Solve and give a reason for each step in this equation. I start out with 3x plus 8 equals negative 4x minus 34. I'm supposed to solve this equation, give a reason for each step that I do. And actually the reason for the first step is given because this was given to me. Now you should be thinking, what would I do to solve this? And I notice there's variables on both sides. Probably what I would do, and you don't have to show this anymore, but I'm going to do this in red to show what I'm actually doing. I would try to get variables on the same side, so I would add 4x to both sides. It cancels out here. Now my next step ends up being, well, 3x plus 4x is 7x plus 8 equals, and negative 4x plus 4x canceled equals negative 34. But I have to give a reason for what I just did. How did I know I could add 4x to both sides? Well, I know I can add 4x to both sides by addition property of equality. I added the same thing to both sides. That's addition PO. What would you do next? Again, you don't need to show this, but since I'm trying to get x alone, I would probably subtract 8 from both sides. Most logical step. That'll go away. I now have 7x equals negative 42. What allows me to just subtract 8 on both sides like that? Well, I can subtract the same number on both sides by subtraction property of equality. Subtraction PO. And finally, what would your next step be? Well, I'm trying to get x alone. It's being multiplied by 7. So I would divide by 7 on both sides. Cancels. I now know that x equals negative 6, right? Negative 42 divided by 7. What allows me to do this step? How did I know I could divide by 7 on both sides? Well, this is division PO. Division property of equality allows me to divide by the same thing on both sides. So using our properties of equality here to solve an equation. It's what you did all last year, you just never had to justify it. We're getting into our first steps of proof by doing this. One more property before we do a new example. You remember distributive property well from last year. Distributive property says that if you're multiplying something by a quantity where there's addition or subtraction, you multiply that thing outside into that sum or that difference. So I know that here I would do A times B, get that product, and then A times C, and that is an addition there. So with distributive property, A times a quantity B plus C is the same as AB plus AC. Let's do an example where I will need to use distributive property as a reason. This one really isn't a property of equality because it's not something on both sides. It's just a property that we can use when you're multiplying by a quantity. Alright, again, solve and give a reason for each step here. This is the problem that's given to me. That's your reason for starting. And what would you do first in trying to solve this? I would probably distribute first. I'm just going to show this. So my new step, my next step would be that's 60 equals negative 3 times 5x is negative 15x. Negative 3 times negative 4 is a positive 12. And then minus that 9x. Well, what did I do from here to here that allows me to get this? I distributed, so my reason is distributive property. By the way, I'm also fine if you just write distribute instead of distributive property for that reason. What would you do next to solve this? Actually, if you notice, I have two x terms on the same side of equals. So what is that called? Well, I would have to combine these like terms, right? I now have 60 equals a negative 15x and a negative 9x is a negative 24x plus that 12. What did we just call this? When you have two terms on the same side of equal, we combined them. That is a reason that you can do for a step. You combined like terms. And I need you to write that all out. What would you do next solving for x? Well, I'm thinking get x alone. I'm going to have to subtract 12 on both sides. So my new step, 60 minus 12, looking at 48, equals negative 24x. What allows me to just subtract 12 on both sides? Well, if I subtracted the same thing on both sides, it's subtraction property of equality. And finally, to get x alone, I would have to divide by negative 24 on both sides. 48 divided by negative 24, negative 2 equals x. I've solved for x. What did I do to get to this last step is I divided by something on both sides of the equation, by the same thing on both sides, which is division, property of equality. So another solving of an equation, giving a reason for each step. Well, really, this is basically a proof. We'll talk in class a little bit, but the only thing that would make this a formal proof is if I did two columns. And at the top, on this side, I would write statements. These are each of the statements that I make. And for each of those statements, I have to give a reason. That's exactly what you're doing. This makes it a formal, it's called a two-column proof. And I would just number these steps, step 1, 2, 3, 4, and 5. And 1, 2, 3, 4, 5 over here. And it will become a formal proof. One more real-life example here. The cost of using your cell phone can be modeled by this equation where the cost equals 0.30 times a quantity m minus 300 plus 39.99. Where m is the number of minutes, m for minutes, that makes sense, that you use per month, only if it's over 300. Solve the formula for m. First of all, just to talk about what this cell phone plan is doing here, it looks like it's 30 cents per minute, but only if it's over 300, so you must get like 300 minutes a month. So if you actually use like 400, if you put 400 here, 400 minus 300, that means you went over 100. So then they'd charge you 30 cents for that 100 minutes. And this $39.99 must be like your basic base charge each month. So let's see. I'm supposed to solve the formula for m, which means get m alone. So I'll start out and just write the problem out exactly the way they gave this to me. And remember, the reason that you write down for starting your problem is that this was given to you. Alright, if I want to solve for m, that means get m alone. And just like the last problem, I would distribute first. So I would get that cost equals 0.30 m, and then I need to do 0.3 times that 300, so I get minus 90. plus the 39.99. Now, what did I do in this step to get to here? I distributed. And I told you can just write distribute if you want, or distributive property is the technical reason there. What would you do next? Remember how I'm trying to get m alone? It looks like right now, though, I have two numbers on this side of equals, so I could combine those like terms there. So now I have that, now I have that cost equals my 30 cents times m, and a negative 90 and a positive 39.99 would be a negative 50.01. What did I do here? Well, I looked at the fact that I had two numbers and I combined those like terms. So combine like terms is actually my reason there. Remember how we're solving for m, which means get m alone. So I'm actually thinking that I should move this 50.01 to the other side so I can get rid of it. So I'm going to add 50.01 to both sides. I know I can't really combine here. I just have c plus 50.01 equals 0.30 m. What allows me to add something to both sides? Well, I'm adding to both sides. That's addition, property of equality. And you know what? I only have one more step here. Trying to get m alone. M is multiplied by 0.3. We're going to divide by 0.3. We're going to have to do that everywhere here. So it looks like you take the cost, you add $50.01, you divide by 0.3 or 0.30, and you get m. We solved for m, we got m alone. What allows me to divide by something on both sides of the equation is division, property of equality. So looking today at properties of equality and distributive property, in order to solve equations, we're basically getting into the beginnings of proof today.